Welcome back to our calculus video series. We're still covering some of the concepts before calculus, some of our pre-calculus concepts, and today we're going to be talking about functions. So what is a function? Well, a function is essentially a machine that converts one value into another one. So for example, if we say x squared, okay, that is a machine that for any given x will produce its square. So if we put 3 in for x, we get 3 squared, and that's 9. So our function is a machine that takes our input value and spits out an output value. So you have an input, you have a process, and you have an output. Input, process, output. Okay? So functions usually have a name. And kind of, if we don't know what to name our function, usually we just do the generic f. Okay? So we would say, in this case, f of x equals x squared. So that means that f is my machine. This is the machine. Okay. So, and then in parentheses, these are the inputs. And a function can have more than one input. You would just simply x comma y or something like that. These are the inputs, and then this is the process. And then your output is what happens after the process. So if I were to say f of 4, well, what I'm saying is I want to put 4 into my machine. I want to put the number 4 as the input to my machine. So 4 becomes x, and so my process is 4 squared, and that's 16. Now, my process can be anything I want, okay? So I can have the process be 5x minus 2. Okay, so that's a different process. And so if I say f of 10, well, that's 5 times 10 minus 2. That's 50 minus 2, which is 48. Okay, so that is the output of my machine. So we can have a machine with more than one input. Can have a machine that has both an x and a y input. And so we can say it's 2x plus y squared. Okay, so now what we're going to do, so what is f of 2, 5? Well, 2 goes in the x spot, and 5 goes in the y spot. So 2x, so that's 2 times 2 plus 5 is in our y spot, 5 squared. So it's 4 plus 25, which gives us 29. Okay, so f of 2, 5 is 29. And you can have more than one machine. We can have another machine. Let's go back to where f of x is equal to change f of x to be 2x minus 1. So let's introduce a new machine, and we'll have g of x equals x squared plus 3. Okay, so now we have two machines. So let's say what is g of x? Let's say g of 4. Well, g of 4, so 4 is in for x, so that's 4 squared plus 3, and that's going to be equal to 19. So what's f of 5? So f of 5 is 2 times 5 minus 1, and that's going to be 9. Okay, so we can have as many machines as we want. We just have to define what they are. So let's do a more complicated one. Let's say we want f of g of 3. Okay, so what does this mean? Well, this means we're going to have our input to f will be the result of processing g with the number 3. So what is g of 3? Okay, well, so g of 3 is going to give us 3 squared plus 3. That's this machine applied to the number 3. So that's going to give us 9 plus 3. It's going to give us 12. Okay, so g of 3 is 12. So that means we can take this 12 and replace it here, because g of 3 is equal to 12. So remember our rules of equality. Any two things that are equal, we can replace one with the other. So we can, since g of 3 is equal to 12, we can put 12 in here. And so what's f of 12? So here we take our 12 and we stick it in for this x. And so that is equal to 2 times 12 minus 1. That's equal to 23. Okay, so here we had a machine that processed the result of another machine. So we can keep on doing that as long as we want. We can have as complicated as we want. We can switch it around. We can have g of f of, let's say, 2. Okay, so what does g of f of 2 do? Well, f of 2 gives us 2 times 2 minus 1. That's 3. And so that means that 3 goes in here. So what's g of 3? Well, g of 3, we did that before, and that one is 12. Okay, so we have, so we can get more and more complicated. We can say, we can ask things like, what is f of 2 times g of 1 plus g of 2? Okay, and so here we have our machine happening twice to two different numbers. Okay, so what is, so we have f of 2 times, and what is g of 1? Well, g of 1 is, put 1 in for x, and we get 1 squared plus 3 plus g of 2, that's going to give us 2 squared plus 3. Okay, so we just have this machine happening twice. So then we say f of 2 times, so 1 squared is 1 plus 3 is 4, plus 2 squared is 4 plus 3 is 7. Okay, so that's going to be, so 2 times 4 is 8. And 8 plus 7 is 15. So we need an f of 15. Okay, so 15, f of 15 is equal to 2 times 15 minus 1. This is 30, minus 1 is 29. Okay, so these machines can get as complicated as you want. But you can also, one thing to notice is that we've used X in both of these. But what X is X is just a stand-in for whatever we passed into our machine. X meant all sorts of things in here. When we passed it 1, X was 1. When we passed it 2 as input, X was 2. And then here, X was the result of this whole series. So X can be anything you want. Additionally, we can also throw in variables. Okay, so let's say that we have the variable P. Okay, let's say we want to know what F of 3P is. Okay, so what is F of 3P? Well, we do it the same way that we did before. It's no different at all. So 3P, we put 3P in for X. So this is going to be 2 times X. And anytime I replace a variable with a complicated expression, I like to put it in parentheses because it reminds me that this whole thing came in as a group. And it will prevent you from making errors later on. Okay, so 2 times 3P, well, that's 6P minus 1. So F of 3P is 6P minus 1. So this is our machine, this is our input, this is our processing, and this is our output. So here, if your input to a machine includes a variable, your output is likely to include one as well. Okay, and we can make this even more complicated. We can say, what is F of G of 2P? Okay, so to solve this, we do it just like we did it before. We start from the inside and we say, what's G of 2P? Well, we put in 2P for our X in our machine. So that gives us 2P. Now remember, we're going to parenthesize this so we're not confused about how this works. 2P squared plus 3. So this is our machine. Okay, so what is 2P squared? We have to square the whole of this. So that gives us 4P squared plus 3. So that's G of 2P. G of 2P is 4P squared plus 3. So now we need to put this into F. So let's erase this. 4P squared plus 3. So now we're going to take the F machine and we're going to process it with this. Okay, so our F machine takes 2 times our input, 4P squared plus 3 minus 1. So that becomes 8P squared plus 6 minus 1. That's 8P squared plus 5. So after a complicated set of operations, we wind up with 8P squared plus 5. But where this gets really confusing is that, as we mentioned earlier, this X is really just a placeholder. So if you're using X in your equation, these X's are not necessarily the same X. They are local to this definition. So this X just means a stand-in. Okay, so we could also have, and this is where people get really confused, we can have F of 5X. Okay, so 5X, it works just like it did before. This 5X, this whole thing, gets replaced for X in the formula. So this becomes 2 times, and where we previously had X, we now put our input, which is 5X minus 1. So that's equal to 10X minus 1. So F of 5X is 10X minus 1. Okay, so it's the exact same process. We put in 5x in our input for our machine. So any place x occurred in our machine, we replaced it with 5x. Okay, so let's look at an even more complicated one. Let's say instead of x squared plus 3, g of x is x squared plus 3x plus 1. Okay, so this is our new machine. And so let's say we want g of 5x. Okay, so again, 5x goes in as our input. So our input is marked by x. So any place in our machine that has an x, we replace it with our input. So that becomes 5x squared plus 3 times 5x plus 1. So 5x squared, that's 25x squared plus 15x plus 1. So g of 5x is equal to that. So we have input, process, and output. And anything that goes in can come out. Now, you can have functions that don't have formulas, because there's a lot of things in life that we understand even if we don't have a formula for. For example, sine and cosine. Okay, so you might remember these functions from trigonometry. Okay, they themselves, so these are the names of some functions. This is the input, and they generate an output. But the functions themselves don't have, I can't write a nice formula for what the functions should look like. There's lots of tables of values. You can have formulas to estimate the functions, but there's no specific formula I can write to tell you what the process is. Okay, so that's one of the benefits of functions, is it allows us to expand our mathematical vocabulary beyond what we can actually write down a process for. And so the only requirement for it to be function is to take an input and generate an output.